What are sectors? They are portions of the circle comprising the arc and two radii. Learn more about them here in Mathematics of Engineering. In order to take the area of a sector, let's compare it with a similar sized circle. By means of ratio and proportion, we can pair up the area of a sector is to the central angle, as equal to the area of a similar circle is to the angle of full revolution. In mathematical terms, a sub s is to theta, as a circle's area of pi r squared is to 2 pi, which is also equal to 360 degrees. For the first example, with the radius of a circle as 6 units and an angle of 100 degrees, calculate the area of the sector. Using ratio and proportionality, we can write a sub s is to 100 degrees as pi times 6 squared is to 360 degrees. All there is to do now is to cross multiply 100 degrees to the other side, making pi times 36 with 100 over 360, which can be simplified as 10 pi. The next example has an arc with length AB, which is equal to twice the length of the radius r of a circle. Determine sector OAB in terms of the radius. The first statement can be written as S is equal to 2r. Substitute this into S as r theta, making 2r as equal to r theta. With r observed in both sides, we can cancel this out, making theta as 2. Use this value in the ratio and proportion for the area of the sector, making a sub s is to 2 as equal to pi r squared all over 2 pi. Again, simply cross multiply 2 to the other side to have 2 pi r squared all over 2 pi, where we can cancel out 2 pi, leaving a sub s as r squared. The third example states the angle of a sector in a given circle is 40 degrees, and the area of the sector is 20 square centimeters. Calculate the arc length of the sector. Using ratio and proportion, plug the given parameters and get 20 is to 40 degrees as equal to pi r squared is to 360 degrees. Through cross multiplication, r squared is taken as 41.38 square centimeters, and r becomes 6.43 cm. Now to solve for the arc, we use the equation S as r theta. Plug r and theta to have 6.43 times 40 degrees, where pi is equal to 180 degrees. S is then solved as 643 over 450 pi, or that is 4.49 centimeters. The next problem uses a figure where AOB is a sector of the circle. We are to determine its area in terms of pi. Using ratio and proportionality, we get a sub s is to 40 degrees as pi times 6 squared is to 360 degrees. Cross multiply 40 to the other side and get a sub s as 4 pi square centimeters. The fifth example also has a figure with a sector of arc 4.4 centimeters, and radius is given as 6 centimeters. The required is the angle measure. For this example, although the figure shows a sector, the solution only includes S as r theta. where r is 6 centimeters and s is 4.4 cm. Placing these parameters in the working equation, we get 4.4 as equal to 6 theta. So theta is 4.4 upon 6 reduced to 11 all over 15 radians.